Hi again. So now let's see how useful is the cumulative distribution function. So in what it helps us. So if I want, for example, to find the probability of x, so we know that probability of x equals 2 is 1 over 4. We get it here from the PMF, the probability mass function. But if I ask what is the probability of x less than or equals to, here you use the CDF, or the cumulative distribution function. So you don't go to the 1 over 4, but you go here 4 over 4. So this is why it is useful. If I ask you to find the probability of x is less or equal than 2, you tell me it is f2, which is, you go here, you get 1 or 4 over 4, or you go here, you say since it belongs to this, so it is 1. Now if I ask you what is the probability of x is less than 3, you say it is f3. We don't have f3 here, but we know it belongs here. 3 is greater or equals to, so it is also 1. Now one important thing you should know is here it is, we said less or equal to, it is f2. But if I tell you strictly less than 2, px less than 2, which means 2 now is not included, so we start from here. So I cannot say it is f2 here. No, it's not f2, but it's f, the f of the previous value. Here it is 1, so f of x is less, strictly less than 2, is f1. Where is f1 here? Either I go here 3 over 4, or I check here. So f1 is when x is greater or equals 1 but less strictly than 2, so it is 3 over 4. So if I want to get px is less or equals 1, it is f1. But if I want px strictly less, px strictly less than 1, it's f0. It's not f1 anymore. So what is f1? f1 is 3 over 4. What is f0? f0 is 1 over 4. 1 over 4. Now imagine I say here p of x greater than 1. We saw only when it's less, but here imagine it is greater than 1. When I say px x is greater than 1, so it means we take only anything that is greater than 1. Here we have to, what is it actually? It's actually the total, everything here, minus less or equals 1. So we can convert this px greater than 1 to 1 minus px less or equals 1. And what is px less or equals 1? It's actually f1. But if I have px greater or equals 1, what does this mean? It means this 1 and 2, which is everything minus this one. So, and what is this one? It is x less, strictly less than 1. So we convert this to 1 minus px, but this time strictly less than 1. And what is px strictly less than 1? It is f0, as we said here. so the previous value. It's not f1, but it's f of the previous value, which is 0. So just remember this. When you want px strictly greater than any number, you convert it to 1 minus px less than this, less or equals than this number. But if it is like px greater or equals than a number, it becomes p of 1 minus p of x less, strictly less than xe. So when it is strictly, you convert it to here less or equals. When it is greater or equals, you convert it to strictly less than. Now the last case, when we want to find the probability of x that it is between two numbers. For example, what is the probability of x here, of x is between 2 and 1? It's actually the probability that x is less or equals than 2 minus the probability of x is less or equals than 1. So it is here in this example, x is less or equals to, which means everything here, but it is also greater, strictly greater than 1. So greater than 1 means this is the only thing that remains here. So the two, only two remains here, which is actually this minus this. So it is f2 minus f1. But if here it is greater or equals like this, it becomes here the probability of this, which is f2, or simply the px less than or equals to, minus this time, since here we have, since it's equals, it's greater or equals, so here becomes, this one becomes px strictly less than 1. So it is f, the previous value, which is f0 minus f0, and this is the result. Let's check it now. So what is x is less or equals than 2? So it's everything 0, 1 and 2, and we know that it is greater or equals than 1, so equals than 1, so it's 1 and 2. So this is the remaining. How can we get this 1 and 2? It's the first one, less than 2, minus this one, which is strictly less than 1. So we need to convert this from less than equal to greater than equal to strictly x is strictly less than. Yeah. So this is why here it's f2 normal, but for this one, if it is strictly less, we take f1. If it is greater, sorry, if it is strictly greater, we take f1. If it is greater or equals, we take the f of the previous value, which is 0. So that's how the cumulative distribution function works actually. So thank you for watching. The next video we'll talk about the expected value x, ex, and the variance.